Standard 10th, Chapter 2, Numbers and Sequences. See important questions, 2-mark sums, solved problems. First question is, prove that the product of two consecutive positive integers is divisible by 2. See, this sum is in your book, it is in page 43, exercise 2.1. It is the third sum. So you can revise this sum. I have given this as the video sum, so you can just go through that. See the second sum, solve. 5x is congruent to 4 mod 6. So you have to find the value of x. So it is also in page 51, exercise 2.3. Sum number 3. So you can go through this. Third sum. See the third sum. Find the indicated terms of the sequences whose nth term is given by an is 5n by n plus 2. Find a6 and a13. So this is also exercise problem. See, it is in page 55. Exercise 2.4. It is sum number 4, subdivision 1. So this also I have given you as a video. All the exercise sums I have given you as a video, so you can go through that. Next sum, fourth sum. A and B are two positive integers such that a power b into b power a is equal to 800. Find a and b. Actually, this is the example sum. Let me do this sum for you. So first you factorize this. So the number ends up with 0. You divide by 5. 1 5s are 5, remainder 3, carry over 3. 6 5s are 30, 0. You divide again by 5. 3 5s are 15, carry over 1. 2 5s are 10. So even number divide by 2. 1 2s are 2, remainder 1. 6 2s are 12. 2 8 2s are 16. 2 4 2s are 8. 2 2 1. So 800 can be factorized as 2 5 into 5. Then 2 into 2 into 2 into 2 into 2. See how many 5s you have? 2 5s. So 5 squared. How many 2s here? 5 2s. 2 to the power of 5. So actually this can be compared with the given one, a power b into b power a. So the 800 can be factorized as 5. See here the base a is 5. The index is 2 here. The same index becomes the base here and the base becomes the index. So a is equal to 5 and b is equal to 2. Or you can take b as 5 and a is equal to 2. And a is equal to 2. Both the way you can give the answer. See fifth sum. If 13,824 is equal to in powers of 2 power a into 3 power b. Question, find a and b. You have to factorize using only the factors a, 2 and 3. And you write the answer of this index. So this is in page 46. Page 46 and exercise 2.2. The sum number 4. So you can see this also in the video. See sixth sum. In a GP 729, 243, 81 dot dot, it is a sequence. Find T7, seventh term. So this sum is also exercise sum. It is in page 72, exercise 2.7, sum number 3. So you can watch this in the video. See the seventh sum. If 1 plus 2 plus 3 plus n is equal to 666, then find n. So the series is 1 plus 2 plus 3 n. This is equal to 666. So n into, this is sum of the natural number, n natural number, n into n plus 1 by 2 is equal to 666. Cross multiply, n into n plus 1 is equal to 6 2s are 12, carry over 1, 12, 13, carry over 1, 13. So n squared, 1 into n, you bring this to the left side, minus 1332 is equal to 0. Now you factorize this, find the factors for this number. Even number, divide by 2. 6 2s are 12. 6 2s are 12, 6. Then again divide by 2. 3 2s are 6. 3 2s are 6. 3. 1 3s are 3. 1 3s are 3. 1 3s are 3. See this number, again it will be divisible by 3. Because you add the digits 1 plus 1 plus 3. 3 1s are 3. So you divide by 3. 2 3 3 3s are 9. 3 3s are 9, remainder 1. So carry over 1, 7 3s are. So here 2 into 2, 37 is a prime number, you can stop here. So 2 into 2 into 3 into 3 into 37. You make it as 2 factors, 2 2s are 4. 4 3s are 12, 12 3s are 36 into 37 is a single factor. So here it is minus, so you have to find the difference. Difference is 1. So this is plus and this is minus. So n minus 36, n plus 37 is equal to 0. So either n minus 36 is equal to 0 or n plus 37 equal to 0. So n is equal to 36 and n is equal to minus 37. So you cannot take the negative value, so take n as positive value, n is equal to 36. This is the answer. It is inapplicable. It is inapplicable. Next question, 8th sum. See 8th sum. Compute x such that 10 power 4 is congruent to x mod 19. So you have to divide this 10 power 4. Actually 10,000 you will get. Is congruent, if you divide by 19, what you will get. So for this, what I do, 10 power 4. So I can split this 10 power 4 as 10 square into 10 square. First you find for 10 square. 10 squared is 100. If I divide this by 19, mod 19, I will get the remainder as 5. 5. Remainder as 5. 95 goes remainder 5. So this 10 power 4 can be written as 10 square into 10 square. So one 10 squared is congruent to 5. Again one more 10 squared is congruent to 5 mod 19. So what is 5 into 5? 25. So if you divide by 19, you will get the remainder as 6. So 10 power 4 is congruent to 6 mod 19. So x is equal to here 6. 9th sum. Which term of an AP 16, 11, 6, 1 is minus 54. Actually the last term is minus 54. You have to find which term is this. So this sum is in page 62 and it is in exercise 2.5, sum number 5. Sum number 5. So this is exercise sum. So I given as a video for you. So you can go through that. See the 10th sum. Write an AP whose first term is 20 and common difference is 8. So here they given A is 20 first term and common difference D is 80. So when you take the AP sequence in AP you will get the sequence as A plus D, and one more D we added, A plus 2D, then A plus 3D and so on dot dot dot. So here in this case A is 20, with 20 I am adding A plus D, 20 plus 8, 28. Then again you add one more D here, 28 plus 8, that is equal to 36. Then add one more D, 36 plus 8 is 44. Then add one more D, 44 plus 8 is equal to 52. At least 5 terms you have to write when they ask you the sequence. So this is an AP sequence, required AP sequence. See the 11th sum. If 1 cube plus 2 cube plus 3 cube dot 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 plus k cube is equal to 44,100, then find 1 plus 2 plus 3 dot 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 k. So this sum is in page 81 in your book and exercise number is 2.9, sum number 3. So you can go through this in the video. See this sum given if 1 cube plus 2 cube plus 3 cube plus dot 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 plus k cube is equal to 16,900, then find 1 plus 2 plus 3 dot 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 k. See here the sequence is given. Question also you have to find the sequence. See 1 cube plus 2 cube plus 3 cube dot 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 k cube is equal to 16,900. Actual formula for this is k into k plus 1 by 2 the whole square. K into k plus 1 by 2 the whole square is equal to 16,900. Taking square root on both sides. Taking square root on both sides. K into k plus 1 by 2. If you take the square root, square will goes off. What is the square root of this number? 16,900. So for 2 zeros you will get 1 0. 169. Square root of 169 is 13. See, they don't ask you the value of k, but just the sequence. What this formula holds for this? The sequence is 1 plus 2 plus 3 plus dot 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 plus k is equal to 130. This is the answer. See the 13th sum. If mn are natural numbers, for what values of m does 2 power n into 5 power m ends in 5? So this sum is in page 46, exercise number 2.2, and the sum number is 2. Sum number is 2. So this is exercise sum. You can go through in the video. See 14th sum. Solve 3x minus 2 is congruent to 0 mod 11. See this sum also, it is in page 51, exercise 2.3, and it is sum number 4. So you can watch this in the video. See the next question, 15th question. Find A8 and A15 whose nth term is an is n square minus 1 by n plus 3 if n is even, n square by 2n plus 1 if n is odd. See here A8, n is here 8, so you have to apply n as 8 in this formula. A15, 15 is odd number, you apply n as 15 in this term. So it is also exercise sum, it is in page 55, exercise 2.4, sum number 5. Sum number 5, you can go through this in the video. See the next sum. A man has 532 flower pots. He wants to arrange them in rows such that each row contains 21 flower pots. Find the number of completed rows and how many flower pots are left over. You have to find the answer for 2 questions. It is also exercise sum. It is in page 42, exercise 2.1. 2.1, sum number 2. See, you can go through in the video and try to do this sum. Next sum. See the next question. Find x so that x plus 6, x plus 12 and x plus 15 are consecutive terms of a geometric progression. So it is in page 72, exercise 2.7. Sum number 4. So you can go through this in the video. See next sum. Find the sum of the series 1 plus 4 plus 9 plus 16 225. See sum of the square numbers actually 1 square, 2 square, 3 square, 4 square 15 square. You can apply the square formula. So the sum is given in your book, page number 81, exercise 2.9. It is the first sum, but it is in the 4th division. You can go through in the video also. See the next sum. Find the number of terms in the AP. It is an arithmetic progression. The sequence is 3, 6, 9, 12 111. Actually this is an example sum. Let me do for you. Here in this sequence the first term is 3 and find the common difference. Second term minus the first term. 6 minus 3 is 3. 3 is added to each of the term. 3 plus 3 6. 6 plus 3 9. 9 plus 3 12 and the last term is given 111. So up to this 111 you have how many terms question. So you have the formula number of terms n is equal to L minus A by D plus 1. So what is L here? 111 minus A is 3 by D is also 3 plus 1. So 111 minus 3 you will get here 108 by 3 plus 1. So if you divide here 3 3s are 9 carry over 1, 6 3s are 18 plus 1. So answer is 37. So this AP has 37 terms. AP contain 37 terms. See the question. Find the greatest number that will divide 445 and 572, leaving reminders 4 and 5 respectively. Find the greatest number, that is HCF, highest common factor. When this highest common factor divide this 445, divide 445 gives the remainder 4 and this 572, divide this 572, So it gives the remainder 5. So you remove this reminders. 445 minus 4, that is equal to 441. 572 minus 5, that is equal to 567. Now you find the HCF for 441 and 567 by Euclid division algorithm, method. So here the greater number is 567. So this is equal to, I divide this by 441. It goes one time, remainder 126. Now take this 441, divide by this 126. It goes 3 times. 3 times leaves the remainder 63. Now you take 126, divide by the 63. How many times it goes? 2 times. 2 3s are 6. 2 gives you the remainder 0. The last divisor is 63. Therefore, HCF is here 63. Therefore, the HCF of 441 and 567 is 63. This is the answer. Next question. Find the least number that is divisible by the first 10 natural numbers. See, actually this question asks in the 1 marks also. Same time they will ask you in the 2 marks also. It is in page 46, exercise number 2.2 and sum number 10. Sum number 9. Sum number 9. I given this as the video. See, you can go through that. See, next sum. If 3 plus k, 18 minus k, 5k plus 1 are in AP, then find k. See, this is an exercise sum. It is in page 62. Exercise 2.5 and sum number 8. Sum number 8. Find a geometric progression whose first term and common ratio are given by. Here in GP, A is given as 7 and R is 6. How this geometric progression sequence AR squared, AR cube, AR power 4 and so on dot. So here A is 7, first term is 7. AR 7 into 6, 7 6 are 42. Again multiply this 6, 6 2s are 12, carry over 1, 6 4s are 24, 25. Then again multiply with 6, one more R is multiplied, 6 2s are 12, carry over 1, 6 5s are 30, 31, 3, carry over 6 2s are 12, 15. Again you multiply with one more R, 6 2s are 12, carry over 1, 1 6 are 6, 7, 6 5s are 30, 3 carry over, 1 6 are 6, 3. So dot. See the next question. 7 into 5 into 3 into 2 plus 3. So this is one term plus 3, a composite number. Justify your answer. So they say that see the sequence of terms multiplied. 7 into 5 into 3 into 2, single term. All the 4 numbers are multiplied with, you get the single number plus 3. You have to show this is a composite number. What is composite number? We can multiply as we can express that as the product of 2 numbers. It may be a prime number also. See, let me take this now given sequence. into 2. This is one number plus 3 is. Take 3 as common. Here 1 3 and here 3 you have in the second term. So 7 into 5 into, when I take this 3 outside, you will get 1 into 2 plus 1 plus 1. So 3 into 7 5s are 35, 35 2s are 70 plus 1. So 3 into 71. See here both the numbers are prime numbers. 3 and also 71 is also prime number. So given number can be expressed as the product of two prime numbers. So it is a composite number. So the given number can be expressed as the product of two primes or maybe two numbers also, any number. So the given number is a composite number. So the given number is a composite number. See, if D is the HCF of 32 and 60, find X and Y satisfying the statement D is equal to 32X plus 60Y. You have to find the value of X and Y. See, actually it is an exercise problem. It is in page 43, exercise 2.1, sum number 8. It's very important sum. You can go through in the video. See the next sum. Find the GP in which the second term is root 6 and the sixth term is 9 root 6. So in GP, second term is root 6, sixth term is 9 root 6. You have to find the sequence. So the nth term is here a r power n minus 1. So second term T2 a 2 minus 1 ar is given as root 6. Let me mark this as equation 1. T6 a 6 minus 1 is 5 ar power 5. This is equal to 9 root 6, equation 2. So divide second equation by first equation. So 9 root 6 divided by root 6. Root 6 cancel. You are getting, see the left side you have to find. Left side is, let me take the left side first. A r power 5 divided by ar 9 root 6 divided by root 6. A cancel. So you subtract the degree. 5 minus 1 is 4. R power 4 is 9. So what is R? So here when I factorize this 9, I can write it as 3 into 3. But I have to write as power 4. So this 3 can be replaced as root 3 into root 3. Again this 3 root 3 into root 3. So 9 can be written as root 3 power 4. So r power 4 equal to root 3 power 4. So r is equal to root 3. So what about a? So substitute r is equal to root 3 in 1. So ar is equal to root 6. So r is root 3 is equal to root 6. So a is equal to root 6 by root 3. So take common root. 6 by 3, that is equal to 6 by 3 is 2. So root 2. A is root 2. So a is root 2 and r is root 3. Now find the sequence, GP sequence. GP sequence A, AR, AR square, AR cube, and so on, dot dot dot. A is root 2, AR root 2 into root 3, root 6. Then with that root 6 I multiply this root 3. So I will get here root 6 into root 3. So same root, you just write 3. So again here with this 6 into 3, again one more root 3 we multiplied. So further you have to simplify this, root 2 into root 6. Here this 6 can be written as 2 into 3. For 2 3's I take 1 3 outside, 3 root 2. Again for these 2 3's I take 1 root 3 outside, 3 root 6. And so on, dot. So this is the sequence, root 2, root 6, 3 root 2, 3 root 6. We can write one more term also, 6 into 3, one more 3. So but this 6 you have 1 3 here. So for 2 3's 1 3, 2 3's 1 3, 3 3's are 9 root 2. You can write one more term also. So this is the given GP sequence. So with that I completed all the important 2-mark questions. You can go through that. The exercise sum means you go through in the video. If you given the question number, you will get the video. You can watch that. So try your best. All the best. Thank you.